can derive some things from it, which are not, they are not entirely related to the main sutra, but these sub things are also important and are useful to us. So we are going to use this Niklam Sutra right now to make deal with some calculation of squares and other things. So let us proceed. So these the things what we are going to discuss today. So coming under curly rays of Niklam Sutra, we are going to discuss three things today: squaring of numbers and squaring of numbers ending in 5, that is a special case, and multiplication of 9, 99 and 999, these numbers with various digits. So till now, if according to Niklam Sutra, what we have learned, if we want to do square of any number, so let us take 12 or 8 case, we are writing their differences with respect to 10 as shown in this on the screen, and we are calculating them. So let us learn one more method which makes things a bit more interesting. So how it when it comes to Niklam Sutra and when it comes to this corollary, what we are trying to learn now, whatever the extent of its deficiency, we are going to reduce it further, or if it is greater than the base, we are going to increase it further. Okay. So now we have to, suppose let us take example of 7. So how much is 7 less than 10? It is 3 digits less than 10. So now what we are going to do, we are going to reduce it further by 3, and we are going to, support it by 3 square. So how does it work? Let us see. So 7 minus 3, which gives us 4, and 3 square gives us 9. And we normally remember these squares, so we can easily verify that this is the right answer. And this is not a particular case. This works for almost each and every number. Okay. So let us take some more cases to understand. So any number if we take, we are going to highlight its difference with respect to the base, and if it is more than base, we are going to add it. If it is less than base, we are going to reduce further. So this is a corollary right now. So how about doing 6 square? 6 is less than 4 digits from 10. So in the same way, we do 6 minus 4 by 4 square. And again, I want to specify this slash doesn't indicate division. It's just a separation where we are dividing the solution in 2 parts and calculating separately. So this gives us 36. Why do we get 36? 6 minus 4 is equal to 2. But 4 square gives us 16, whereas since the base number is only 10, we can take only one digit on the right hand side of the slash. So we will take 1 and we will shift we will take units digit, that is 6, and we will shift the 1 which is in tens digit to the left side. So that makes 2 plus 1, 3. And similarly, we are going to deal with some more numbers. 11 is above 10, so we are adding to it. Notice this one, guys, this pattern repeats for all the numbers. Okay. Now coming to 12. 12 is 12 plus 2 digits above 10, so 12 plus 2 by 2 square. Similarly, 30. And this applies for all the numbers, so let us see some high numbers. Large numbers, 91 square. 91 is 9 digits less than 100, so 91 minus 9 slash 9 square. Similarly, 97 holds good as well. 97 minus 3 by 3 square. And see, if this even holds good for such a big numbers as 108 and 989, we don't have to really write those 2 steps as well. What we write in a normal Niklam Sutra, this corollary makes our job further easier. So, one more example, 993 square. 993 is again 7 digits less than 1000. And this is just for reference to show that you can, escalate the number to any high and it still holds good. And now this whatever square of number what we are calculating, this can be explained algebraically as well. Previously, I discussed that anything like 993 is there, so we can say 1000 minus 7 whole square, and which we can represent it in the form of a minus b, so whole square. So we can calculate in that way, a square plus 2ab plus b square. We can also do that instead of traditional calculation. And also we can do this way. We can take a square minus b square, and we can make advantage of this fact. How? Let us see with an example. See, now we are doing 93 square. So what we will do? We will take b as 7. So, and we will do 93 plus 7 and 93 minus 7. Now, the wonderful part of this is 93 plus 7 is will always become 100. And whenever we apply this a square minus b square formula, what happens is out of a plus b or a minus b, at least one will give you the whole number, that is 100 form. Okay, so that gives you 8600 plus 49. So this is what we are doing actually. We are not writing those zeros every time we are doing calculation by Nicolam Sutra, and instead we just represent by slash. So finally the answer is 8649. So this is just a way of verifying it. So we can take one more number, 108 square, whatever we have done previously. We can also check it like this. 108 plus 8 into 108 minus 8. 108 minus 8 will give you 100. So that makes our things easier. 11664. Similarly, a larger number, 988 square. So now let us discuss one special case. Again, the same another corollary out of this Nicolam Sutra, where we have formulated a small tip regarding how to calculate square of number whose digit ends with 5. Okay, so 15, 25, 35, these things become rapid easy at the moment you learn this trick. As you can see, 15 square is written as 1 into 2 slash 25. So what happens is, when last units digit is 5, whenever you square it, it mandatorily results in 25. The last two digits will be 2 and 5. This is, the common thing. You can take it for granted. Coming to left hand side of the part, what will become is, take the tens digit of it. Right? 15 instance 1 and 5. So if you take this 1, what is the next digit to it? It is 2. So 1 into 2. So whenever this digit must be multiplied with its next digit. So 1 into 2. 2, 25. So let us take one more case. See, when it is 2, it becomes 2 into 3. So whatever the digit is, we are going to multiply it with its next digit. And the right side part will always be 25. Similarly, 3 into 5, 3 into 4, 4 into 5, 5 into 6, 6 into 7. So this is how it's going to be. We can even check it wonderfully for higher numbers. 10 into 11. See, this is 5. Like, we are going to separate it, and whatever is the remaining is the left hand side part. So this becomes 10. 10 into 11. Here it is 11 into 10. 12 into 13. 17 into 18. So this is how it is. Look how easier it has become. Like, you can calculate any number square of which units digit is 5 in a rapid, easier manner with this corollary. And one more case is, this extends to one more thing. We can also see one more case where we take two digits, and these two digits when multiplied must have a condition, and we can apply the same corollary. What is the condition? That if you take AB and AD, the rules are, first digit of both the numbers should be same, which is A, you can see it. And again, B and D should be related in such a way where B plus D should be equal to 10. And we have a special way of calculation of same corollary. So let us see how that unfolds. See, now we are taking 27 and 23. That is what happens again? We are going to multiply this first digit in the same way as before into the digit next to it. Since here the first digit is 2, we are going, what is the next digit of 2? It is 3. So we are multiplying 2 into 3. And these two digits which sum up to 10, they multiply and give us the right hand side part. Right. Previously it was 5, 5. So 5, 5 becomes 25. And now it is 7 and 3. So 7 into 3 becomes 21. Can you see the similarity, guys? It is one and the same. Same corollary applied to a bit seemingly different scenario. If you take 96 and 94 similarly. So 9 is the digit which must be multiplied with its next digit. What is that? 10. So 9 into 10 becomes 90 and 6 fours are 24. Similarly 87 into 83 which gives us 72, 21. You can see the color difference where I have indicated B and D in a separate color and A is in a separate color to avoid confusion. Right. I hope you understand it. And one more small special case what we are going to see in it is when we increase the number. Okay. This whole calculation naturally holds good when we see. Now B plus D is equals to 100, 1000, etc. This is a special case where we are going to multiply again. So 191 into 109. What happens? 91 plus 09 gives us 100. So these are indicated by purple color. And whereas whatever the remaining part is, that is our left hand side part. So 1 must be multiplied into its next digit 2. And 91 into 9 becomes 819 on the right hand side. But notice one thing, here we add 0. Okay. And we will discuss this case in exclusively later on in further episodes. But please note the added 0 in case the B and D is equals to 100 and 1000. Similarly, you can observe other two numbers as well. 793 into 707. Again, 93 plus 7 gives you 100. And 7, so 7 must be multiplied with its next digit 56 and 0 included. And 93 into 7 becomes 651. Similarly, 884 into, 884 into 816, which gives you 720 plus 1344. Again, this carrier thing comes because here the base is 1000 seemingly, and we can place only 3 digits according to 1000 as base. So we are going to carry 1 here. So that becomes 721, 344. So now let us check one more part. This is one more corollary. I just represented in this way to make it look, easier to understand. So here this corollary we took this case like where we multiply numbers with 9, 99, etc. But what's the specialty of it? See, you just don't have to remember the multiplication table, nor you have to go for other special tips. And the beauty with 9 is it is almost the last digit of single digit numbers. So that gives us an advantage. So now let us see how this corollary unfolds. Okay. So here is the 9 which we are multiplying with each and every number. So we take one case, 9 into 2, right? So we have to reduce this digit, whatever we are multiplying with 9, by 1. Okay, previously we have added, plus 1 and multiplied. That is, we are multiplying with next digit. Here we have to go for previous digit. So this 2 becomes 1. So on the left hand side. And now what is this 8? This 8 is nothing but the difference between this 1 left hand side and the whole digit 9. So 9 minus 1, 8. I hope you are getting it. Now let us try with one more example. 9 threes we are calculating. Okay. So this 3 is reduced by 1, which makes it 2. And this 2 is difference with respect to 9 is 7. Coming to 4. 4 becomes 3. And 9 minus 3 gives us 6. Similarly, 5. 5 becomes 4 and 9 minus 4 becomes 5. Similarly, 6 becomes 5. Similarly, 7 becomes 6. 8 becomes 7. 9 becomes 8. And 10 becomes 9. So, I just included this as a table form as well to avoid confusion if someone felt a bit clumsy. So, this is just my way of trying to explain. Since I don't have much experience, please try to understand. So, when it comes to 99, we are going to follow the same, but this is also, a beautiful representation. We can calculate very large numbers and in a very quite amusing way. So, 99 into 11. This 11 becomes 10 and 99 with respect to 10 is, difference is 89. 99 minus 10 is 89. Similarly, 99 minus 11 is 88. 99 minus 13 is 87. Similarly, 40, 86. 99 minus 14, 85. 99 minus 15, 84. 99 minus 7, 16. You can see it is 83. So, this is it, guys. We have some more interesting cases over here. What are the interesting cases? So, we can say further things now. These are smaller multiplications what we have discussed earlier by Nicolam Sutra, and in some simple cases where we are applying the present corollary as well. So, previously 9 sevens, we know it is 63, but now if we apply this particular corollary, 7 becomes 6 and 9 minus 6 becomes 3. Similarly, 77 becomes 76 and 99 minus 76 becomes 23. So, same cases. 999 into 979. 979 becomes 978 and 979 minus 979 minus 978 brings us to the answer right hand side 0 to 7. Similarly, this case is just for reference. See, what we didn't notice earlier, we actually, if we notice, mathematics is much more fun. So, this is one more special case where we multiply, different digits under some special, special procedure. If you please try to understand, this is not mandatory, but, enthusiasts can try to have a look. So, 37 into 9. Right. So, here the special case is, we are multiplying 3 by its, not multiplying, we are increasing this first digit, that is we are making it 4 and we are subtracting it from the 37. Okay. So, that becomes 33. And what about this one? We are taking the difference of 7 with respect to base 10. 10 minus 7, which is 3. You can also represent it in this manner. So, we are reducing this 3 plus 1, 4 from 37, which gives us 33. And we are subtracting this second digit 7 from the seemingly base of number 10. So, we are assuming a 0 here, which we do it for normally. And so, we are subtracting it from 7, which gives us 3. This sounds a bit clumsy, but let us have a look with some more examples. See, 122 into 9. So, what happens is, here, so units digit is 2, so we are writing 12 separately. And what is the next digit of 12? 13. So, we wrote 13 here, minus 13. You can see it clearly. Okay. And this is second digit 2. This one. We have borrowed it. Okay. This one. Units digit is borrowed here. So, we are taking its difference with respect to them, which gives us 8. And here we are not actually keeping 0 and borrowing 1 digit from here, but instead we are just taking the difference of last units digit with respect to 10. So don't borrow any numbers here. So 122 minus 13 gives us 10, 109. So the final answer is 1098. This is the answer of 122 into 9. Similarly, 112 into 99. So here the number is, here we are taking the base as 100. So previously what we took the base as 10. Okay, if you observe, we are taking 9. When we take 9, we take base as 10. And when we take 99, we take base as 100. So we are including 2 digits and this is 1 digit. So 1 plus 1, 2. We are reducing 2. And whatever the units part here is, 12 is carried here. So we are reducing 12 from 100 gives us 88, and this 12 minus 2 gives us 10, and 1 comes forward, and so the answer is 11088. This is a bit seemingly difficult to process right now, so let us discuss it further in detail. Thank you.